Hey everyone, it's Diana from the Understand Energy team here to tell you the most important things you need to know about wind energy. To get us started, I've got my wind turbine earrings on. I've got my wind turbine t-shirt on. So some things to know, big picture about wind energy. It provides 8% of the world's electricity, 10% of the United States electricity. We use wind energy just to produce electricity, and over 99% of the wind energy today is onshore in the US. It's over 93% in the world. Both onshore and offshore, though, are growing sectors. So why is wind energy growing? Big things are it's abundant. We have wind in a lot of places. Very low cost. Our fuels are free. Our technology is getting cheaper all the time. And it has very low environmental impacts. And that leads to a lot of policy and financial incentives to have wind energy be part of our electricity system. There are, of course, things that we have to manage about wind energy, including opposition to wind, being near sites that people don't want to see the wind turbines, the avian and bat concerns, where we have impacts between birds and bats with the wind turbines, infrastructure for transmission, the constrained supply chains. These are other things that are challenging aspects to our wind energy. So each wind turbine blade is shaped just like an airplane wing. And that means it's thicker on the front and it tapers off to be thinner on the backside. And what that does is when the wind flows over that wind turbine blade, it has to go at a higher velocity over the top than it does over the bottom because it's got a further distance to travel. And what that does is lower the pressure above the wind turbine blade and cause it to lift or turn. And so that is what's driving the wind turbine blade to turn, and we're able to take that rotational energy and turn a generator and make that into electricity. Now, these wind turbine blades are enormous. Think football field size in some of our modern wind turbine blades. So when we make a wind farm, we're putting several wind turbines connected together with electrical wire that is connected up into a substation. So you're gathering the electricity that's being generated from all these different wind turbines into a single substation, and then usually stepping that up to a higher voltage to get it onto the grid. Now, these wind turbines have to be spaced pretty far apart because you don't want them interfering with each other. So they actually are only taking up about 3% of the land space. The rest of that land can still be used for other purposes, for agriculture, for grazing, for wildlife. So it's got this dual use of the land space. Our wind turbines are getting cheaper all the time, and there's a few reasons why the electricity being produced is getting cheaper and the turbines themselves are able to extract more and more energy from that wind. The first thing is wind turbines have gotten a lot bigger over time. So in the 80s, they were relatively small. Wind turbines today are enormous. Winds up higher tend to be faster and steadier. And that matters a lot because the power in that wind varies with the cube of the velocity. Double your wind velocity, you get 8 times more power. The other thing is they're sweeping a much bigger area. So you're getting a lot more capacity per turbine. That means you can get a lot more electricity production per acre of land. So lots going on here. We've had a lot of advanced tech in terms of how we're orienting our wind turbines and things like that that are all driving down costs and making them more efficient. With that, wind is actually one of the lowest cost sources of new electricity. And what I'm showing you here is unsubsidized costs. And what that means is this is without subsidies that are for wind production or renewable energy subsidies or tax subsidies. Without any of those policy subsidies, wind energy is one of the lowest cost sources of new electricity. So let's talk about the resource. We have a huge untapped wind energy resource base all across the world. And you can see that in this map, the red and orange areas where we have the most wind. Here in the United States, we have one of the best wind resources in the world. And you can see that kind of in the plains area in the middle part of our country. You can see we have enough wind energy potential to power the United States 10 times over. Globally, we have enough wind energy resource to power the electricity needs 30 times over. It's a very big resource. Where are most of the wind installations? They are in China. So this is just showing you for onshore wind. So where that 93% is, most of it is in China. You can see it's almost 3 times what the US has. A lot of wind is also installed in Europe if you think of that as a region, but the most by far is installed in China. It's where most of the growth is happening as well. But Europe actually has the highest percentage wind in their electricity mix. And so when we're talking about in terms of the percentage generated of their total electricity generation, more of their electricity generation comes from wind than it does in other regions. And that's important because we have to think about we're taking this intermittent resource, right? We can only make electricity when the wind is blowing. And we're figuring out ways, we're using tools to actually integrate that at very high rates. And there's a few tools that we can do that with. So grid operators, these are the ones that are maintaining the reliability of our electricity grids. They have to balance supply and demand at all times. And so you can imagine if you have a resource that's intermittent, that gets more challenging. But we have ways to deal with that. One of the things that we can do if we have large grids, lots of transmission, we can have geographical dispersion of these wind farms. And when you have that geographic diversity, you have wind blowing somewhere, and it really smooths out your wind electricity production over the entire grid. And that makes that wind energy much more reliable resource. The other thing, we have battery costs that are coming down. And so now we're seeing near firm wind be more cost effective than other electricity resources. So that pairing that wind electricity with batteries, that's going to make the wind energy a more reliable resource. Pairing it with other resources like hydroelectricity that can be very flexible, pairing it with solar PV, which a lot of times wind and solar might have both be intermittent, but on opposite times of the day. We can have demand response. There are other ways to balance out the grid and keep it reliable with very high penetrations of wind. Let's talk a little bit about the resource and what's happening in the United States. So I already mentioned that the Central Plains, amazing wind energy resource. That doesn't mean it's the only place. There are quite a few places, and you can see them in little pockets. One of the areas in the US that doesn't have the best energy resources for wind is the Southeast. So they're really going to be looking to either have transmission from like the Central Plains to the Southeast to bring that wind energy, that wind electricity to those demand centers, or they're going to be looking for other resources. So not surprisingly, the wind energy capacity in the United States is really concentrated in the middle of the country where we have that great wind energy resource, and in the Midwest. Texas is by far the leader in terms of states that have wind energy capacity. So I'm showing you how that capacity growth translate into actual electricity generation. Since about 2005, it's been an exponential growth in electricity generation from wind energy. And you can see that it passed up hydro in about 2019 and has just continued to grow. Now, on this chart, you see a very interesting thing. It's the first time this has happened. Wind energy electricity actually went down in 2023, not because we weren't installing or we didn't have wind capacity to make electricity, but because the winds actually were low in 2023. So this is one of the challenges that we will have in wind energy, is that we base where we want to put wind turbines on historical data. And with climate change, some of those places may experience a shift in the wind energy regimes that can actually reduce the capacity for electricity generation at those sites. So that's onshore. Let's talk about offshore for a minute. China is also the leader in offshore wind energy installations. You can see it has half. Europe has quite a few. The United States has almost none. All right, so why do we want all this wind energy? The fuel is free, it doesn't change cost over time. There's no burning, there's no water use, no drilling, no refining, no waste, no greenhouse gases, no air pollution. These are all drivers in terms of the low environmental impacts as associated with wind turbines. Now, I mentioned it earlier, we do have impacts in terms of birds and bats, and those must be managed. Now, I'm showing you a chart of all sorts of different things that are human related that impact birds. And you can see there's a variety of them, all the way from house cats to oil pits to electrical lines. Wind turbines also, and One of the areas that is a growth area right now is using AI to reduce bad impacts. And then, of course, the banana or NIMBY. So, NIMBY is not in my backyard. Banana is build absolutely nothing anywhere near anyone. So, that is another barrier that needs to be managed. And then there's a whole range of policies that are incentivizing wind energy because of those low environmental impacts, um, because of the low societal impacts. These are just ways that policy or business are playing a part in driving wind energy forward. We expect to continue to see the growth in wind energy capacity, both onshore and offshore. We're expecting those to continue to increase because of all these drivers we've talked about: the low cost, low environmental impacts, availability and abundance of this resource. If you want to know more about it, please check out our other resources on the site. Thanks for hanging.